Version control. Let's talk about Git specifically. So Git is a distributed version control system, which means that everyone who has a copy of the repository has the entire history on their computer. So you don't just have the current version on your machine. You have all the versions. So you can always get back to previous versions without actually getting anything from a server or anything, because that's just the way Git is designed. So it's not like GitHub is the source of truth for your repository and your laptop just has the latest version, but you need to talk to GitHub if you want a previous one. Both places have a copy of the entire thing. But if you make a change one place, you need to push it over to the other. So let's talk a little bit about how that works. So the current state of your files is called the working copy or the working directory. If we do a git status right now, we see it's up to date, nothing to commit, working tree clean. So that means my current directory, my working directory, which is always just the current state of the code as it is right now, is the same as what's in my history. If I make a change, like I make a change to the README, the first project for extern bootcamp session 3. Maybe we want extern bootcamp 2018, parentheses, session 3. There we go. Now we've made a change. And I say git status. Now I see changes not staged for commit, modified readme.md. So now my working directory does not hold exactly the same thing that my actual history does. But this is what's in my actual folder here. If I look at what's actually in my folder, I'll see I see just those 4 files, and they are the version of those files that I see in my editor, right? This includes the change to README. But we saw that Git actually stores things in a little hidden directory called .git. So if I open that up, here's all this. And my full history is stored here in this objects directory. This is the full history of my project. And there's a file in there called index. And that keeps track of the current state of all of my files. And it'll say, okay, so the file readme.md, the working copy does not match the final thing. So it just has a little note in there about that. If I want to add it to my history, there's a step in between. So here's what the basic workflow looks like. Everything to the left of the dotted line happens on your laptop. So you have your working directory. That's your code as it stands right now. The head, that is the history of your project, all previous commits, including the most recent commit. So if you want to take your current changes and put them there, you must first add them to the index or stage them for commit. You can call this the staging area. So that's, as you can see, what git add does. Git add takes your changes from your working directory and adds them to the index or stages them, which you have to do before you can commit them, which makes them permanent. So if I say git add dot, that takes all changes from my working directory and stages them. So now if I say git status, I see changes to be committed, modified readme. So now my changes to readme are in my working directory, but they've been added to the index because I ran git add. So what happened there, as far as this hidden git directory goes, is it actually added it to the objects, the same place that it adds real commits. The difference is there is no commit message pointing to it, but the index has been updated to say, okay, this blob of changes that's sitting in the objects folder, this stuff is staged. So basically for each file that's listed in the index, it tells it which version of that file is in the working directory, which version of that file is in the index, and which version of that file is actually in the history. So once I've staged it, there's a little note in here that says it has been staged. So now if I were to type commit, that would be included. If I were to make another change, however, you know what? The parentheses are silly. And this project uses vanilla JavaScript, ECMAScript 2015 plus. We're not messing with that old stuff. So now if I say git status, you'll see changes to be committed, modified readme, and changes not staged for commit, modified readme. So my working copy has the most up-to-date version of readme, but only that first batch of changes has been staged. So you can totally stage some changes within a particular file even, and not others. Not only can you stage some files and not others, you can actually stage some of the changes from a file and not others if you want that to be part of a different commit for whatever reason. Yeah?
So I'm trying to understand all this like jargon you're using, and what is the difference between like adding the working directory to the index and just like saving the changes?
So if you don't have Git at all you're doing is saving files on your hard drive, right? So the difference is there's this hidden directory here, which not only has, did I close it? Why did I do that? It not only has the files as they are right now, it has them as they used to be too. So the last time that you committed, that version of the file is still there. So if you make changes and like can't recover, you're like, oh crap, it used to work and now it doesn't. And I can't get back. I can't hit undo enough times to get back to where it actually worked. Well, if you're using Git, you can actually change all of your files at once back to an entirely separate version of the whole project.
So Git, when you have Git on your computer, not only does it like exist on the cloud, it also exists on your laptop. So when you save it, it exists on your laptop and inside a folder that Git has created.
That's right. So all previous versions are on your laptop. You don't have to talk to GitHub to get them. All previous versions are already there. In fact, we haven't even talked about GitHub yet. So everything I'm talking about is true, even if it's only on one machine. Yep.
It's just when I try to do open.git, I believe that's...
On Windows, that would be start. It would be start instead of open. Yeah.
Okay,
yeah. So you should never have to actually look at this folder or make any changes to it. That's why it's hidden. Yeah. But for demonstration purposes, there is stuff going on as you're doing all these things. Even though it looks like your actual files never really change, there's stuff going on under the hood as you're typing these Git commands. So now we staged some stuff, and that does add it a reference to it inside Git. But if we want to make it permanent, we need to stick a label on it. So what you're basically doing is making checkpoints, right? So just like in a video game, you just won some big fight. It makes a new checkpoint. So now if you die in the next section, you can always get back to that checkpoint, right? And in some games, it'll continue to make checkpoints, and you could go back 3 stages if you wanted to. So you're doing that with your code. And that's a good idea because, if you got through a really hard battle, and then you keep going, and you die, and you're like, oh my gosh, I can't believe I have to fight that one again, but I'd already won that one. So don't forget, make your checkpoints, folks. So all we've done now is stage, though. So they're not permanent, right? They're living here. If we want to commit them permanently, we have to run git commit. And when we do that, we want to write a good message so that we can look back through our history later and see what was going on here. So git commit -m and type my message. Update readme with a project description. So now if I type git log, I can see update readme with a project description is there, update a fancy paragraph is there, update the heading with the buttons clicked, add a button in the day 1 homework from yesterday. It's all still there, and I could get back to any of those versions if I actually needed to. But all of this is still happening. Did I not commit? What's going on here? Oh, right, I'd only staged some of it, right? Okay. I meant to stage more of it than that. So here's a little trick. I'm going to add my new changes, and really I want them to be part of the same commit. So I'm going to say, and if this is too much, just don't pay attention for a second, but if you're interested in knowing how to do this, git commit -- amend to change my previous commit. And I could also at this time change the commit message if I wanted to. I don't need to change the commit message. I just wanted to recommit. So now I've changed that commit. If you don't put -m when you commit, it will open up your default text editor. One of the steps in your setup was to configure code as your default editor, because otherwise, if you're using a Unix machine, it'll run Vim, which if you're not accustomed to Vim, you will have no idea how to even quit, much less how to actually enter text. I like Vim, but it's not the best for teaching in an environment such as this, because we've got enough new things to learn. So anyway, now I have my history. I've made all these changes, but they still only live on my laptop. So if we want to actually sync them with the cloud, we need some service like GitHub, or we at least need another machine. GitHub is one of many services that do this. There's like Bitbucket, and I think there's one called Beanstalk. There's GitLab. There's a bunch of them. but we were using GitHub. And you may remember yesterday after we created our repository, we copied 2 commands out of here. Remember that? So we created an empty repository, then we copied 2 commands. The first one was git remote add. So when you have another machine that you're syncing the repository with, that's called a remote. That's to the right of the dotted line here. And you can have multiple remotes that you sync with. Generally, if you only have one, you're going to name it origin. So that command was git remote add origin. And then you have to tell it the address, the URL of that repository. And that was the rest of that command, which was https://something, right? So that was the first command that we pasted in, git remote add origin. And that sets it up so that now we have a remote called origin, and it's GitHub. The second command that we ran was git push. So push is how you take the code that's in your local history and add it to the code on a remote. Pull is the opposite. Take code that's on the remote but not on your machine and pull it back down. And the full command was git push -u origin master. So we have to tell it which remote, origin, which branch on the remote, and we haven't talked about branching, and we're probably not going to talk about branching a whole lot because it's just not time. But if you want to read more about Git, that's a very important topic. You can have entirely separate histories that you manage for the same repository. But one important thing here is this -u, which is short for --set upstream. But -u, as you can see, is quite a bit shorter than that. And what that means is, from now on, when I say git push, I mean origin master. So don't ask again. So from then on, I can just type git push, and it knows which remote to sync that with. So this is a little more detail than you necessarily need. As I continue to commit and push and everything, I'll keep showing that picture sometimes and periodically reminding you that this is what's going on under the hood. The important thing to remember is it is important to make checkpoints along the way as you're working. It is important to write good commit messages as you do it so you can retrace your own steps and so that others can retrace your steps. The other people on your team, the people looking at your homework on Friday, i.e. us, and future you. Because remember, the developer whose life you make miserable by using terrible commit messages may be you. That's right. So that is a quick overview of Git. Keep in mind, I will keep harping on this a little bit. We do update the notes on the website every day, and there's always some more information about the topics we talk about. So for today, today's notes are already up there with everything except the afternoon videos. And there are 3 links that go into more detail about Git. We don't spend that much time talking about it in class, so if you want to learn more, here are 3 pretty good guides that start from the beginning. So if it just doesn't quite make sense to you yet, feel free to look those up. Spend your study time that way if you want to. And hopefully, if my explanations don't make any sense, maybe someone else's will. Search YouTube, look for one. There's a pretty good conference presentation that someone did using Tinker Toys to show how branching works. That's a good one. So anyway, between all those sources, hopefully you can get it. Oh, so funny. Anyway, yeah.